Corporate finance practice problem using Excel. Cost of debt after tax interest rate calculation. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. We use that to populate into the blue area on the right-hand side. We're looking into the cost of debt after taxes, but basically backing into, after having known the cost of debt after taxes, the interest rate. Something less common in practice, but still could be useful to understand how the calculations work. Very common or quite likely in, say, a book problem. We have the similar type of situation with many kind of areas within finance that we don't really want to memorize another formula. We just want to note that this falls into a particular formula, look for that unknown, use our algebra in order to solve for that unknown. So what we have here, the cost of debt after taxes, so this is not the interest rate, but the cost of debt after taxes, so the interest rate's going to be something higher than that. We know the tax rate is the 35%, and then we'll have our example problem down here where we'll have the debt of the 100,000. But let's first just consider these two pieces of information. So we're going to plug this into our formula looking for the interest rate. We're not looking to basically memorize another formula. We want to just note that this plugs into our normal formula here, which is the cost of debt after tax calculation, which would be the debt rate or the interest rate times 1 minus the tax rate. In this case, the cost of debt after taxes is known, which would be the 10% equals the debt rate, the unknown right here, times 1 minus the tax rate, 35% the known. Once we plug that into our algebraic equation, we can solve for the debt rate, the unknown, and work the algebra to figure it out that way. I'm going to use our tables to kind of figure this out up top. And once again, I'm going to format the table as I normally would and not rework the equation algebraically to solve for the debt rate. And then think about how we can kind of back into the debt rate in this format. So we could say the interest rate normal calculation would be the interest rate, and that's the unknown. So I'm going to put that on the outside. That's what we do not know. I'm going to just make up an interest rate right now just to complete the calculation, 0.1. And then we're going to have the calculation of 1 minus the tax rate. Let's do it this way. 1 minus the tax rate. Colon, and hold on a second, colon, there we go. So we're going to say 1, and then the tax rate is going to be equal to the 35%. I'm going to make both of these percentified now. So we got 100 minus the 35, underlining this, and let's not underline this one, only underlining the second one. And that's going to give us a subtotal, which I'm going to put in the outside. This is going to be the 100% minus the 35%, making that then a percent numbers group, percentifying it. I'm going to indent these two, alignment, indent, subtotal, indent again here. And so then I'm going to underline the 65, underline here, and this is going to give us our cost of debt after tax. So we know what this answer is. This should be the 10%. So if we know what that is, I'm going to make this a percent numbers group in percent. We can kind of back into the answer up top, right? Because this times this should give us the 10%. So we should be able then to take this equals then this divided by this should give us, I'm sorry, one more time. This should equal then this divided by this should give us our 15.38. So we can see, even if you see a kind of basic calculation like this, to just format it in the normal table kind of format and back into it. You can also use the goal seek. So the goal seek in any kind of situation like this, we'd say, okay, it's 0.1. This wouldn't be as useful in a test scenario, but it could be useful in practice when you have a worksheet or something that you're working with commonly. And you would say, okay, normally it would be this 10%. I just made up that 10% times the 65. And then I want this end number to be 10 here. So I can use goal seek to change this cell to get to the end number to what we need it to be by going to the data tab, the what if analysis goal seek. We want to set this cell to be the 0.1 by changing then the 10% up top, and then we're going to say okay. So then that's another way we can basically find this item up. Now let's do the algebra, rework the algebra here, solve for the debt rate, and then I'll just make another table down here, which will basically give us the bottom line number being the debt rate. So let's solve for this. We're going to say then the cost of debt after tax then is going to be the 10%. This is going to be the 10% that we know. Going to make that then a percent by going to the home tab, numbers, percentifying it. And then we have the same information here, which is going to be the 1 minus the tax rate, which is going to be then 1. And then the tax rate, same thing here. And that's going to be equal to the 35%. 35%. Let's percentify these two by going to the numbers group, percentify. I'm going to underline the second one, font group, and underline. And that'll give us then our subtotal, I'll call it subtotal, which is going to be the 100 minus the 35. And making that a percent, numbers group, percentifying it. Going to grab these two and then alignment, indent. I'll align the subtitle again and indent it again. That'll give us the end result then being the debt rate. The debt rate, which will be equal to the 10% divided by the 65. And then I'm going to make that a percent, number group, percentifying it, and add some decimals there. We'll add a few decimals. So there we have it once again. Let's put an underline, font group, and underline. So this would be the most straightforward way to do it. All we did was rework basically the algebra of this equation, plugging in for the unknown, solving for the unknown, and reworking our table for the debt rate. Now let's just plug this back into our longer example and imagine we know what the debt is, this 100,000, because sometimes this makes it a little bit more concrete when you're not just talking about percentages and you basically add the debt in there. So if I didn't understand or remember these two formulas, I might then say, well, what if the debt, let's apply an amount to the debt and kind of think through it. So we would have our kind of our longer type of format here. I'll make this a little bit smaller so we can see this. This is going to be the interest calculation. And I'm going to say the debt then. Let's pick up the debt, which we're going to imagine this time to be the 100,000, multiplying that times the rate, the interest rate, let's say interest rate, which is what we don't know. So I'm going to make up a number here. I'm just going to make up the 10% again, 10%. I'm going to put there for now. That would give us the interest, then the interest that will calculate interest, which will be the 100,000 times that 10%. So that's the normal calculation that we would normally kind of go through. I'm going to then select these items, go to the alignment, indent interest down here, and indent that again. Then let's calculate the tax benefit based on what we know. Tax benefit, and that would be then the deductible interest, which now would be that 10,000 times the tax rate is what the benefit would be. So that's tax rate would be the 35%, making that a percent, numbers group, percentifying it, font group, and underlining. That's going to give us our tax benefit on the outer column, the 10,000. This should be, 10,000 times the 35%, the deductible interest times the tax rate. And that would be in this case, the 3,500. Underline, font group, and underline. Let's indent these three by going to the alignment, indent, tax benefit, alignment, indent again. So that's going to give us then our cost of debt after taxes, which is going to be then the 10,000 minus the 3,500, assuming the 10% as the interest rate. So then if we wanted to calculate our percent cost of debt after taxes in a percent format, cost of debt after tax percent then is going to be, let's make this a percent colon, is going to be the cost of debt after taxes, which is going to be that 6.5 compared to the debt itself, which is the 100,000. And then we'll subtract those out, or we'll divide those out. This is the cost of debt after tax percent. And then I'm going to get rid of the colon on the end here. And let's indent these, Go into the alignment, indent, indenting again, alignment, indent again. We're going to then take the 6.5 divided by the 100,000, percentifying that, numbers group, percentify it, adding a couple decimals, underlining the 100,000 font group, underline. Okay, so then we can basically kind of back in then and say, okay, that 10%, what does it need to be to get to the bottom line number of this one, where we need it to be, which is that 10%. So this 10% is just a random number, and we're trying to get the bottom line to be that 10%. So I could then change this to 11. Oh, not that one. Hold on. Undo. Undo. I could then change this one up here to like 11% and so on, 12%, until the end number gets to where we need it to be. I can basically make an algebraic equation out of this if I wanted to, and then basically solve for the unknown up top. Or we can use GoalSeek if we had an Excel worksheet in order to figure this out. Once again, that would not be as appropriate to do. You can't do that in a test situation where you don't have Excel and GoalSeek, but it could be useful to work this different ways in Excel so you have a better understanding of it in your mind, what it actually means, which helps commit it to memory, and then be able to rework these problems easier, having a better understanding of them. So in any case, I'll do the GoalSeek up top. We're going to go GoalSeek, what if, GoalSeek, and we'll just say, let's change this cell to be 0.1 by then adjusting this cell and say like, okay, let's do it. And there it is. It's been done. We wanted to do it and now it's done. So there it is on the 10%.